How did the caravel sail in a direction opposite to the wind if they didn't have engines? This question bothered me for many years, and I only found out how it worked when I worked at Nautica magazine. I'll leave it for the end of the video because it's really good. But stick around until the end because there are a lot of cool questions, like this one. Iber, how can I tell the difference between a star and a planet just by looking at the sky? Before anything else, let's understand why the name is planet. After all, we're not on a flat place. Shouldn't it be called rounded or spherate? Planet comes from Greek and means traveler, wanderer, walker. And that's why it has this name, because a basic difference between a star and a planet is that if you look at the stars one day, then the next, and the next, and the next, you'll notice that some stars, which are very few, move in the sky, they make patterns, they walk across the sky. Because they're not stars, they're planets, and planets move in the solar system. You can see that they change position over time. So that's the first difference. But it's not something easy to notice, because on the same day, if you sit there, you won't be able to see the planet moving like an airplane. It's much slower than that. There's a second difference. Stars, when you look from here, are just tiny points of light. So they twinkle. It blinks a little. It moves a bit. Kind of like a flickering firelight. And this happens because that light, which is really thin and comes in a straight line, passes through our atmosphere. Sometimes it hits a spot that's a bit warmer or a bit cooler, and it gets deflected. This also occurs with light from planets. Planets don't emit light. Instead, sunlight reflects off them, so we see them like the moon. However, there's a key difference with planets. With any small telescope, you can see it's a disk, not just a point. Disk allows more consistent rays of light to reach here, so it twinkles much less. Still, it's not easy to tell the difference between the twinkling point of light and the one that doesn't. There's a third difference: planets have color, D. You can see the color a little more. So, Mars, for example, will look like a reddish star, and Venus, a yellowish white. But let's agree that white, yellowish, and white are almost the same thing, right? It's not the simplest thing in the world to tell the difference between a planet and a star just by looking at the sky with the naked eye, is it? The way isn't really easy. It's to install an app like Skyview or Stellarium on your phone, which are two that I use here. You type in Jupiter, look, and know you're seeing Jupiter. You take a telescope and point it there, and then you can find out that, in fact, that's a planet. During the day, the sky is blue, but at night, the sky is black or transparent because we can see the moon, the stars, and everything else. Before talking about the sky, let me just say something about these tech shirts I wear. If there's anyone who guarantees it won't lose its color, it's Insider. If you buy a tech t-shirt like this and it fades, they'll replace it. The guarantee isn't just for the first few washes or limited to 2 uses. I think, in the end, it's really just a marketing thing. Because in practice, the shirt doesn't fade, you won't need that guarantee. Just so you have an idea, this shirt I'm wearing is one of my first from Insider. It's about 4 years old. When I look in my closet, I don't even know which one is new, which one is old. I don't even pay attention to that because they all look new. This one here is about a month old. Look at that. So if you want to invest in a shirt that lasts a long time, check it out. At the Insider store, use the coupon Manuel de Mundo and you'll still get a 12% off deal. Now, let's explain the sky thing. In practice, I'm going to take an aquarium full of water and drop a few drops of milk in it. This milky water represents our atmosphere, which is full of particles and gases that can scatter light. Back here, I put some Christmas LEDs, which are the stars. So right now it's nighttime. You can see the stars, even with the atmosphere in front. You can still see several bright dots. The problem happens when the sun comes. It will light up the atmosphere. Look, the light spreads out, especially the blue light. It hits the air molecules and spreads completely. It paints the sky blue. That's why the sky is blue, and at that moment, you can't see any stars anymore. When night comes, it becomes transparent again. During the day, the stars disappear. At night, they reappear. You can see. So the sky isn't black at night. It's transparent. And during the day, the atmosphere doesn't let you see the sky. I just think our sky simulation deserved your thumbs up, didn't it? Why isn't there an Aurora Borealis in Brazil? Is it related to temperature? To begin with, what is this so-called Aurora Borealis? They're a kind of cloud that appears in the sky, a very beautiful pattern. Sometimes it's purple, pink, green, and you can only see it very close to the poles. If it happens near the North Pole, we call it the Aurora Borealis. If it happens near the South Pole, we call it the Aurora Australis. And from Brazil, you can't see it. You can see it But it has nothing to do with the cold. It happens near the poles because that's where the ends of the giant magnet, which is planet Earth, are. In our book Cruel Doubt, the first one, the yellow one, there's a drawing here of planet Earth representing the magnet it has inside. That's why a compass works. Earth is a giant magnet. But why does the Aurora Borealis occur? Because the sun, besides the light that comes here, releases a bunch of particles, like protons and electrons, that travel from the sun to here. We call this the solar wind. And when these particles reach planet Earth, they are attracted to the poles. The geographic poles, the south and north poles, are also the poles of Earth's giant magnet. And then, when the particles collide with our atmosphere, this spectacle of lights happens that we see and call the aurora. In short, it happens near the pole not because it's cold, but because that's where the tip of our giant magnet is. Why is it that when we try to remember something, we look up, does that really happen? I'm trying to see if that's ever happened to me. No, I think you're mistaken. I don't think that happens to anyone. Why is it that when we chew corn and defecate, it comes out whole? What a beautiful scene, right? But let's get to it. Well, first of all, you're not chewing the corn properly, if that's happening, okay? Because if you chew it, it won't come out whole. But here's the thing, the core. The inside part of the corn, it's mainly made up of starch, which is basically the cornstarch we cook with. Cornstarch is a super important food for the human brain, for animals. It gives us energy. But the outer part, the shell of the corn seed, is made of cellulose, which is the same material as paper and cotton, and that's something humans can't digest. So if you eat cellulose, it will go through your entire digestive system and come out whole. That means if you take a closer look at what came out, you'll notice that it's hollow inside. Only the shell is left, so you didn't chew it properly. Otherwise, you would have broken it into pieces. How does ultraviolet protective clothing work? Does it have an expiration date? And what about regular clothes? Don't they protect against ultraviolet rays? What is ultraviolet to begin with? They're ultraviolet rays. It's a type of light that comes from the sun and we can't see it. And that's also why it's dangerous, because we take it for granted. Oh, today it's not that sunny. There are a lot of clouds. I can go out. It's not quite like that. This light can still reach you and you can't see it. First of all, the clothes we wear every day do work as protection. In fact, if you go out in the sun wearing a shirt like this, you won't get burned. If you stay in the sun for just a little while now, you might be fine. But if you go out and spend the whole day under the scorching sun, like at the beach, surfing, or whatever, will you get burned even with the shirt on? And then these shirts and so on came out, which have ultraviolet protection, and you don't need to put on sunscreen where you're wearing the shirt. It's a big advantage because, let's be honest, it's really annoying to keep putting on sunscreen, especially if you're in the water, since you have to reapply it every 2 or 3 hours, and you end up getting burned anyway. The technology of these fabrics varies, but generally it's like this. Either they have a very tight weave with no holes for sunlight to get through, and the fiber is also made from a more opaque material that doesn't let light pass through. So it's basically like wearing a hat or using an umbrella. Or the fiber is a bit more transparent. If we look under a microscope, a cotton fiber is almost transparent. I'm saying this and already thinking that I should be looking under the microscope in a moment. I'll get it. And then you have a treatment, like a sunscreen that's applied to the fabric, so it becomes less transparent and protects more from the sun, from what I've read. These clothes keep their protection for a long time, and of course as they get older, the weave opens up a bit more, and so on. It offers less protection, but it's still safe clothing we can use confidently. Let's get the microscope and examine the cotton, right? Look, the tip of a thread, 10 of cotton. Looking up close like this, under the microscope, it looks like it's made of glass. You can clearly see that the fibers are transparent. From a distance, it's white, but up close, it's transparent. Let me see if I can zoom in more here. Look, it makes a perfect bone ball. Here in the back workshop, there's a kind of creepy box, bones. And you know what's inside? Exactly, bones. We got these cattle bones here to try to make a perfect bone ball. But I'll confess to you that when we cut the bone, it gave off a terrible smell. We found out that inside, it was much more porous, much more full of holes than we imagined. And in the end, we couldn't figure out a way to make the perfect bone ball. So if you have any suggestions on how to make a perfect bone ball, leave them in the comments and we might try to do it. Do ants poop? If so, why have I never seen ant poop? Ants do poop, of course, but maybe you haven't seen it because ants are very hygienic creatures. I don't know if this applies to all species, but I've seen several studies showing that inside the anthill, ants have a special place to poop. They don't just poop anywhere, like dogs do, where we have to pick up after them as they go. But I'll say that even if an ant suddenly gets the urge and poops in the wrong place, it would be hard for you to notice because it's something very small, much smaller than an ant. So you'll see it as if it were dust, a tiny piece of sawdust floating around. Which came first, Ecuador or the equator line? I'm referring to the name Ecuador. It sounds a bit strange for you to have said that. I'm referring to the name Ecuador, but I asked this question to ChatGPT, and it got confused. It said, the equator line came first, since it's been around as long as Earth. But I was talking about the name Ecuador, and it missed that. It was good that you pointed that out in this case. Just to remind you, the equator line is what divides the northern part from the southern part of planet Earth. It is the same distance from the South Pole and the North Pole. So thinking geographically, it's something that has always existed. Any planet that rotates, you will find the axis, the poles, and there will be an imaginary line that divides the planet in two. And this name equator means equalizer. Equalizer means something that makes things equal. Do you know why? Because at the equator, the day is the same length as the night. So it's a line that makes things equal. This name is old. It's about 400 years old, but the country isn't. Before the Europeans arrived in America, Ecuador was part of the Inca Empire. After that, it became a Spanish colony, just like Brazil was a colony of Portugal. But it wasn't divided up. The Spanish colony was huge. The countries that speak Spanish today were all mixed together. In fact, when independence happened, Ecuador didn't immediately become a country. It was part of a group of countries up here called Gran Colombia, which included Venezuela, Colombia, Ecuador, and Panama. Then, at that time, the province of Ecuador emerged, which was like a state that, in 1830, when it became independent, finally became a country with the name Ecuador. In short, the country's name comes from the name of the line, not the other way around. Why is the camera lens round, but the photo is rectangular? You know that one of the things I like most to do here on Manual do Mundo is to open up cameras. So let's go. The lens is in fact round. And if we look inside the camera, you'll see a mirror. But when the photo is taken, in the back, the little space where the light comes in, which is there ready to receive the light, where the film is, you'll see that it's rectangular. But anyway, you need to have a lot of patience, right? Are you using a camera there that was, I don't know, your great-grandfather? Nowadays, things are technological, and they don't work like that anymore. Oh my god. This here is a Sony a6600. It's the camera we used until last year on Manual do Mundo, a digital camera that records video, records in 4K, and everything. I'm going to open it, and do you know what's in the back? Exactly the same thing. It's a rectangle, but instead of being film or a place to put the film, it's a digital send. So what happens is, the lens is used to take the image that's in front and project it onto the back of the camera. That image at the back of the camera will be stored somehow. It can be on film or on a sensor. But what stores the image is rectangular. It's as if we're cropping the projection that's happening there. How can I get to know you? The easiest way to get to know me is at a book launch event for Manual do Mundo, and we have several every year. In the first half of this year, there will be 6 launches here. We'll keep launching Mysteries of the Universe, which began late last year. And we'll also release the big biology book, March 22nd, Santo André on the 23rd, Sorocaba, the city where I was born, April 12th, Londrina, the 13th, Curitiba, the 17th, Belém, and the 18th, Macapa. If you're not in these cities, allied. More launches are coming in the second semester. Or if you visit Macapa for the launch, we can see the equator line. Why is the middle finger called the middle finger if it's the biggest one? Yeah, the middle finger should be the ring finger or the index finger, right? Those are the ones in the middle. Here, this word middle actually means in the middle. So if your mom asks, did you do well on the test? You answer, so. It means you're in the middle. You didn't do well or badly. And that's why this finger is called the middle finger. Because it's exactly in the middle of the hand, between the other fingers. If I color water with dye and let it evaporate, shouldn't the cloud become colored? Usually, the dye doesn't evaporate along with the water. The water evaporates by itself, by the way. A very good way to filter and remove impurities from water is to distill it. Let it evaporate and then condense it. What comes out on the other side is usually pure water. This won't happen 100% of the time. Some things can evaporate along with the water, but I don't think that's what's going to happen with the dye. Let's test it in practice. Classic blue dye from Manual do Mundo. I'm going to pour a little bit here at the bottom of this pan, Add a little water on top. It'll turn that beautiful blue. Look at that. And let's turn on the stove to see what's left. The cloud story is mostly proven as water evaporated and condensed on the colder scissors, turning back into liquid. You can see that there's no dye in this liquid. It's just water. It's transparent. The question is the bottom of this pan blue or not? There's absolutely nothing left here. All the dye stayed in the pan. It didn't go away with the water. Tell us, Iber, why does a clutch exist? Wouldn't it be possible to make a combustion car with just two pedals, like an accelerator and a brake? After all, several automatic cars only have an accelerator and a brake, but the clutch is there. And you don't see what this clutch is for. It's a part that disconnects the wheel from the engine. If this part wasn't there, when you started the car, it would turn on and the car would start moving right away. There wouldn't be any way around it. And then when the car was moving, if you had to stop at an intersection, the engine would stall because the engine needs to keep spinning somehow. So, when you press the clutch, the engine disconnects from the wheels and it can keep spinning without moving the car. From what size? Something is considered microscopic when it's at a size that humans can no longer see properly. You can no longer understand what's happening there. This happens at around 0.2 or 0.1 millimeters. That is 1 millimeter divided by 10. If there are two little dots there, you can notice the difference between them. My 5-year-old nephew asked me, and I didn't know how to answer. Why do we wear underwear? Is there a reason? I know it was my nephew who asked. There are many different reasons. The first one is hygiene. Down there, in the lower part, there could be some leakage. Some kind of skid mark, which wouldn't be good if it happened directly on our pants, shorts, skirt, etc. You end up changing your underwear daily, but don't need to change your pants every day. There's also a matter of protection, since the private parts are more sensitive, especially with jeans, for example. There's a serious risk for boys, after they pee, when they zip up, of catching something they shouldn't, and underwear protects against that. And there's also a matter of support, the same function that a bra has for women. Underwear has for men. And there's also the issue of moisture. It's a more intimate area. If you run, you'll sweat a lot there, just like under your arms. And underwear can absorb some of that moisture. Why are there pink dolphins? Or in this case, the pink river dolphin. First of all, this animal isn't exactly pink. It's gray and turns pink over time. River dolphins have some parts that are still gray and others that are pink. What happens is that this animal loses its pigmentation over time. It stops being gray. And what's underneath starts to show. In fact, when it gets hurt, the part that was injured will never be gray again. It stays pink. And this pink color is because of the blood vessels. Since the blood is red, and when it passes through the skin, we can't see the red completely, so it looks pink. But the crazy thing is that this happens with humans too. We also, without the pigmentation of the skin, are pink underneath. My grandfather had a skin condition called vitiligo, where you actually lose pigmentation. You lose melanin. And then he started to turn all pink. If we look at a pig, for example, which has very little hair and sometimes no pigmentation, you'll see that it's an animal almost as pink as the pink river dolphin. Why don't we throw all the trash we produce into space instead of on Earth? Let me tell you something. I always get suspicious of these very technological solutions for a common problem we have in our daily lives, when the real solution would be for us to produce less trash. But let's go. Why can't we throw it into space? First, it wouldn't be easy. We would have to send this trash into space and make it go away. Really, it would have to leave Earth's orbit. Why? Because if you throw this trash with low speed, it falls back to the ground, and that's not a good idea. With a little more speed, this trash will go into orbit. It will become a satellite of planet Earth, and then we will be creating space junk. Trash keeps floating up there, blocking rocket launches, and will eventually fall back to Earth. So, ideally, this trash would leave orbit and, I don't know, head toward the sun and disappear for good. But the bigger problem is that this is extremely expensive. I got a price chart of how much it costs to take a kilo into space. It's on Wikipedia. You can check it out if you want. It's down here below this video with all the links and all the sources for the questions. But just so you have an idea, the cheapest price, which would be for the Falcon Heavy, is $1,500 to take 1 kilo. How many kilos of trash do you produce per week? So, let's try to produce less trash, recycle, recycle, or do things that are a bit more within our reach regarding the mess we make. All right, Iber, have you ever lost money to a scam? If so, please tell us. Look, I'll tell you guys that here in Brazil, it's hard to scam me. In fact, we even have a video here showing how we scammed the scammer. But in Argentina, once I almost fell for it, and the second time I actually did. The first time happened when I was walking down the street in Salta, a city in the north of Argentina, and out of nowhere, there was a wad of money on the ground. A wad this big, in pesos, tied up like this, just thrown on the corner. I saw something on the ground while walking, but didn't pick it up. My rule is not to pick up things that belong to others, since the owner might return for it. Finders keepers. Losers weepers. Look, the person who lost it was careless, but what you find isn't yours, right? Let's agree that there's an owner, and ideally, it should go back to the owner. But anyway, I didn't pick it up. And when I got to the next corner, a guy came up to me and said, "Did you see that wad of money there?" I said I saw it, but I didn't pick it up. He was like, "What do you mean you didn't pick it up? Let's get it. Let's take it for both of us and split it." That moment, I had a strong feeling I was about to be scammed. I watched 9 Queens about scams in Argentina and thought, I'm in a place where people love scams. I said, "No, I don't want to know. It's not my money," and goodbye. I disappeared. I got out of there, and I have no idea what kind of scam that was. I imagined that guy was going to split the money with me. And then one of his friends would show up, say he's from the police, and ask me for some money to catch me, arrest me, something like that. About 15 years later, I was in Argentina again, in Buenos Aires, riding a taxi with Mari and the girls. And the peso, the Argentine money, is really devalued. At the time, it was about 1 to 40, meaning 1 real could buy you 40 pesos. And it was even kind of hard to do the math because the value changed every day. You had to carry a wad of cash because their money wasn't worth anything. Anyway, we took the taxi, went to a place that was kind of far, and kept watching the meter. Because you get kind of anxious, right? You worry the ride might be too expensive and wonder how much you'll spend. The price kept rising and ended up at 9,000 pesos. I thought it was pricey, but paid immediately just to leave. It was a beat-up taxi and the driver was in a bad mood. I was with the girls. I just wanted to get rid of that taxi driver. But I had a feeling something was off. It was about 200 reais, and it wasn't even that far here in Sao Paulo. 200 reais? With that amount, I could go from Sao Paulo to Guarulhos Airport, which is far away. It's an expensive trip to another city, so that price seemed kind of strange to me. So we ate at the restaurant, did whatever, and decided to take another taxi to go back. Do you know how much the return taxi cost? Exactly, 900 peso. In other words, the comma that separates the decimal place was erased. He did that on purpose. The Brazilian there, who doesn't really know the prices, who's kind of desperate, and just wants to get out of the taxi, ends up paying 10 times more for the ride. That ride was worth 20, not 20 reais. It was a scam that didn't take much money from me. Some people here lose tens of thousands of reais. Since then, I've been very careful with taxes in Argentina. How do rockets follow a route in space? If we're going to Mars, which path do we take? By global positioning system. When I was in school, I thought it was kind of strange that astronomy was a subject more connected to physics than to geography. And why is that, right? Isn't astronomy a lot like what we study? On Earth, we ask where the sun, moon, and galaxies are. Why is it connected to physics? Is it because space isn't stationary like Earth? Things move, and things move in orbits, one thing orbiting another. It's a complex system, and that's why you study this more in physics. So, there isn't a fixed map of the solar system. All the planets are spinning at the same time. To go to Mars, we have to leave here calculating where Mars will be when we arrive. It's kind of like in a soccer game. When you're going to throw the ball to someone, you throw it thinking that the other player will run and meet the ball up ahead. But that's not all. You also have to take into account the pull of gravity. So, when you're leaving Earth, you'll be overcoming Earth's gravity. And then you'll be pulled by Mars' gravity. So there's this whole gravity game you have to play and take into account. And the calculations are pretty complicated. There are different ways to get there, and it's nothing like going to another city. Using global positioning system, it's much more complicated. Why does a poison become less potent after its expiration date? Shouldn't it be the opposite? When things expire, don't they usually become more poisonous? Not studying here, how do we define the expiration date of food? There are 3 things that are taken into consideration. The first is safety. If that food won't spoil and won't harm you, if it won't cause food poisoning, then yes, we can say that the food becomes a kind of poison, but it's rare for food to actually turn into a poison. Second, it's nutrition. Whether that food loses its nutritional value, if at some point we eat it, And it doesn't really make much of a difference anymore. And the third thing is that the food can change its sensory aspects. In other words, it can start to smell weird, taste weird, lose its texture, so it's not as tasty anymore. And let's be honest, it's very likely that the first thing that will happen to the food is that it will get a bit weird, start to smell strange, something like that. This doesn't mean it's spoiled, but it does mean you can't sell it anymore. You buy cream cheese expecting a certain taste, but if it tastes like strange butter, you can't sell it anymore. It's not poisonous, and something similar happens with poison. It's like it loses its nutritional power. It won't work as well anymore. Usually, you'll use poison, I don't know, to kill some insect or something like that, or use it on a crop, and then it expires, but it won't become more poisonous. What materials and how do you make a nuclear reactor at home? Well, the first thing you'll need is uranium, preferably uranium-235, which is the one that's more radioactive. You place uranium in a pressure cooker with water and must precisely measure the distance between each uranium piece, because if you put them too close together, it could explode like an atomic bomb, but if you put them too far apart, nothing will happen. So, at the right distance, the water will start to heat up and boil. Then, you take a little pipe coming out of that pressure cooker and inject it into a turbine. This turbine has to be connected to a car alternator, okay? You can take the car's turbo and connect it to the alternator, which is that part of the car that generates electrical energy, and that's it. If you survive all that radiation, you have a beautiful and terrible nuclear power plant, but it will only work if you put blue dye in the water. What do you think about electric cars? Do they have a chance to become popular here in Brazil? Look, I think they're already popular here in Brazil. Everyone is wondering if their next car shouldn't be electric. Let's think a little about the economic advantages and disadvantages of this type of car. Because let's be honest, these are the things people are going to take into consideration when deciding to get a car, right? The electric car has a very simple mechanism. So it's a car that practically doesn't have an engine. The engine is only electric. There's no radiator, no clutch, no gearbox. You don't have to change the oil in the oil pan. The second thing that's very interesting is that electricity is much cheaper than fuel per kilometer driven. Depending on where you charge and so on, it can be about 5 times cheaper. For those who use the car a lot, it makes a big difference. And the third thing, which isn't economic, but I'm sure it matters a lot when buying, it's that it's a car with a lot of torque. As soon as you touch the accelerator, it delivers all the torque without needing to build up speed, without needing to be at high revolutions per minute. Unlike a combustion car, it pulls a lot. It accelerates really fast, even the cars that aren't that powerful. And then comes the downside. The worst of all is that it's still a very expensive car. If you compare an electric car to a similar combustion car, it's nearly twice as expensive. The range is often low, making long trips without recharging difficult. These cars still don't sell well. Most are imported, so finding parts may not be easy. And the worst part is that we don't have a distribution network. So, if you go on a trip and your battery runs out along the way, you run out of power and get stuck. At worst, you'll need to tow a generator trailer. Considering all this, maybe for a lot of people it's not the right time to have an electric car now, but very soon, these problems will start to be solved. There are already electric cars that are cheaper, and there are more and more places to recharge. So, when it gets easier, I'm sure they will. It's really popular in Brazil right now, but we'll probably start by using a lot of hybrid cars before we get to electric ones. Jansen, who's behind the camera, is making fun here, saying that in Sao Paulo, it won't work very well because the power goes out all the time. In fact, it's raining a lot now in the summer. And here at Manuel do Mundo, I don't know. We've already lost power about 3 times because of rain and everything. But he has something really interesting to say about electric cars. When the power goes out, you won't be able to charge the car, obviously, but you might be able to use the car's battery to power your house if you have a system set up for that. You could run pretty much any appliance in the house, including the shower, heavy stuff, and electric iron, with the energy that comes from the car's battery. In other words, you can turn the electric car into a giant power bank. Isn't that pretty good? We've reached the answer to the last question. It's very likely that you clicked on this video to find out. After all, why is a sailboat able to go against the wind? It doesn't make any sense, but it does. Let's imagine that the wind is coming from the left side of the screen. Okay, and this here is an airplane wing. It's been cut. The airplane is on the side. It's back here, and we're looking at it. The wing is cut. The wind hits the wing. What happens to the airplane? It goes up because of the shape of the wing, which pushes the wind down. And as a result, the airplane goes up. So look how strange this is. The wind is coming from here, but the airplane goes up. It goes over there. Now, this here is no longer an airplane wing. It's the sail of a boat. And The boat is in this position here. This is the hull of the boat, and this here is its sail. All nice and pretty. Look how crazy that is. It's like with airplane as the wind is from the side and the boat heads that way. This is a very common situation. In sailing, the wind hits from the side and not from behind the boat. So here, we've already understood that the boat is able to go at 90 degrees to the wind. The wind is hitting the side, and the boat moves forward. Now, I'll make a drawing commonly used in sailing classes and nautical studies. I put the wind here now. The wind is coming from above. Okay, and we have 7 boats, each one going in a different direction. The red arrow is the direction of the boat, and the white one is the position of the sail. So, you see that the boat going with the wind. Yes, the wind hits the back of the sail, and these two that are going almost in the direction of the wind. The wind is also hitting the back of the sail from here on. No, the wind is already hitting almost in the same direction as the sail. And up here as well. If you look at these two boats up here, they're already going against the wind. So, because of what I explained at the beginning about the airplane wing, the boat can sail in several different positions in relation to the wind. The only direction it can't go is exactly against the wind. That's why there's no 8th little boat here, but Iberê. That's really cool. You could see, yes, that it works, that I learned some things, but the 8th little boat doesn't exist. You said it goes against the wind, but it doesn't. Okay, let's suppose you're taking a trip in this direction. You have to go against the wind. So what do? Head in this direction. Then turn when you get further ahead. You go zigzagging against the wind. Of course, that takes work. Of course, the boat goes much slower than if the wind were in your favor, but you can still go against the wind by zigzagging using these two positions here. To be honest, today we even have an audience here behind Manuel do Mundo. They told me they understood this explanation, but I'm always left wondering if it wouldn't be worth making an entire video about this, because every time I look at this diagram, it seems more complicated than I imagined. Share your thoughts and questions in the comments, and I'll try to answer them in the next video.